Okay. Well, thanks for the invite, Greg. Wanted to talk a little bit about the Dwarf 2. It's one of the smart telescopes that you've probably heard about, but it's small, so I'm calling it a smart mini telescope. I think David is either getting one or has one, and I'm not sure if anyone else in the audience has one tonight. But if you do, I'd like to hear about your experience. I'll go through a little bit about the sort of ecosystem that the Dwarf 2 is fit in, and the other options that you have, and then go through the app really quickly, and then end up with some sample images. So maybe first of all, why do I care about small, cheap telescopes? Well, back in 2017, I helped run an eclipse experiment called the Citizen Kate experiment, where we had 70 telescopes across the path of totality. We tried to make those pretty cheap. They were small, they were 60 millimeter aperture, but the price per site ended up being more than I wanted. It was about $3,500. And this was, for instance, too expensive for a high school group to purchase on their own. Luckily, we got some grants from NASA and NSF back in 17. And excuse me, after the eclipse, the volunteers were given their equipment and they continue to use it today. But what we're going to do for the 2024 eclipse is something a little different, but the idea is the same. We'll have a set of telescopes across the path, and we're calling it the Dynamic Eclipse Broadcast Initiative. We're funded for 20 sites. This might actually be 60 sites now. We're still waiting to hear details from one of our NASA proposals. But the goal was to make it cheaper and faster and better, to follow the NASA creed. But the idea is that we could hope some volunteers would actually purchase their own equipment, and that would relieve the pressure for us to get grant money to buy the packages. So we've been testing out a lot of different telescopes, and I'll talk about some of these. But besides this project, they're just personal reasons. I like to travel, and we take only a backpack when we go traveling, so it makes it a little hard to bring a lot of equipment. But I've been using a Tupperware bin, a food storage bin that slides into the outer pocket of my backpack as sort of my limit for what I can bring. And so I'm really interested in cramming as much material into that as I can. And it just is, useful for impromptu outreach events when we're on travel. So that's the motivation. Now, as you know, there have been some smart telescopes on the market for a while. Vaonis came out with the Stellina in 2018, which I think was the first one. And now they've got the Vespera in 2022. These are 80 and 50 millimeter refractors, respectively. And they're smart, so you set them up. They calibrate themselves, so they know which way they're pointing, as long as they can get GPS information about the location and the time. They do a couple of plate solves across the sky at different angles, and they solve for the tilt of the tripod and the azimuth of the North Celestial Pole, given the location. So these really kicked off the sort of movement in this direction, I think. But for some reason, I was not inspired to take a look at getting these. So I wanted to, and following up on that, Unistellar has also come out with 2 smart telescopes. These are reflectors, and they're bigger. They're 114 millimeter diameter. The EV Scope and EV Scope 2, I think both of these have what they call an eyepiece. It's an electronic display, basically, on the telescope that you can kind of look through, although you're not looking through the optics with your eye. And then the Equinox 2, which just came out, does not have that, and it's cheaper. But still, when I saw these, I just was not inspired to go out and purchase one. And so I wanted to try to quantify what was going on and maybe justify my thinking, or at least understand my thinking about why I didn't buy one. So these telescopes, they're not meant to look at Jupiter or Saturn. They're not really meant for high resolution work. So what people have been doing is imaging extended objects, nebula or galaxies or star clusters. And I tried to introduce this performance parameter that would give you a handle on how well your system could do that. So I came up with this, and there might be better ones. Let me know if you have ideas. But it's basically the number of pixels on the sky, so the size of your detector, excuse me, times the light gathering ability of the telescope, so the collecting area, and a divide by 1,000,000 down here. So like I said, if you're increasing this parameter, it helps you when you're capturing large diffuse objects. But again, it's not a good parameter to use for high resolution work. So the key then was to look at this parameter, this performance parameter, versus the price of the systems. So here's these sort of initial smart telescopes, aperture, F number, they're all around F4, Stellina's F5. Mirrors, a doublet and a quad for the lens systems. And so you can get the number of pixels by multiplying NX and NY. And then this is that performance parameter, the number of pixels times the collecting area. And here's the price. So now if you plot this on the log scale, I found this relation, which, made me think, well, these are all sort of filling the same sort of area in this parameter space. This is log, so it's not really a straight linear relation, but in log space it is. So the Vespera and the Stellina are down here, the EV2, and then the EQ2, the Equinox 2, is down lower, probably because it's missing the eyepiece equipment. So at this sort of level of price performance, I just really wasn't interested in any of these, purchasing any of these myself. But then in 2021, Greg Holloway came out with a 3D printed device. We're looking at a lot of Raspberry Pi instrumentation at this time. And he basically came up with his own 3D printed, what he called a microscope. So this is not quite a smart telescope. You had to polar align it yourself, but it used a Pi HD camera and a Canon 300mm focal length lens as the feed optics. And then once you were aligned, you could go to and look at all sorts of objects. The Pi was controlling the motors. It was cheap because of the 3D printed parts. And I thought this could be a really, big market disruptor. But in the end, it got very little notice from people. I think some people in the maker community picked up on it, but not a lot of interest otherwise. But to kind of copy what Greg was doing, we put together some Raspberry Pi imaging systems. And so I used a really cheap telescope, this Orion 100mm f4. This is not the Skyhunter mount, but it's a Cube Pro. But still, a Skyhunter mount can do a better job cheaper than this. And we were able to get some decent, basic astro imaging. Here's Orion and the solar surface. But also we can get some real science quality data. So, people who are doing solar imaging know that the sun in white light shows you these fluctuations, these solar oscillations. These are acoustic waves on the surface of the sun, causing different patches to heat up and cool down. And with the right Fourier transforms, you can actually show the dispersion relationships of these waves. And so this is, bordering on real science, real citizen science that you could do with this really cheap system. So how do these fit into that price performance category? Well, the microscope is down around the 7,000 level of performance, but this 100mm reflector is up near the 30,000 level of the unistellar stuff. So on the graph, you can see that they're significantly cheaper. The Pi camera plus the cheap off-the-shelf equipment is down here. Microscope, Greg's thing is kind of in the middle. But again, they're not fully automated, so I have different symbols here for them. So in this sort of plot, in this 2D plot, where does the dwarf come in? Well, they came out first with something called the tiny scope, which wasn't too interesting. I think it was mostly for terrestrial work. I didn't put it on here, but eventually they had a Penn, a tip tilt mount that you can get, but really didn't have a lot of astronomy smarts, like none really. But that was their first effort. And then finally they came out with a Dwarf 2 design. And here's a cutaway model of it. Here's the actual Dwarf 2, if you can see that. But it's got an elevation axis and then an azimuth axis as well. So the cutaway view shows you that it has sort of a periscope layout for the main optics. It's got two cameras. So this side, this side has the main telephoto lens, and then there's a wide field camera over here. So there's just a small straight through system here that's not really shown. But this has everything you need, right? So it can do plate solving. It controls the azimuth and elevation motors, can point around the sky. It's fully what I would call a smart telescope. It's just 24 millimeter aperture. So, you know, at 500 nanometers, that's only 5 arc-second resolution. So again, you're not going to be doing planetary work with this. Although I'll show you some examples of people who haven't given up the ghost on that. The pixels are 3 arc-seconds, although mostly it's been 2 by 2. So I think mostly you get 6 arc-second pixels. And so I backed it back in February 2022, and almost a year to the date, it finally arrived on my door. And Dwarf Labs is not being really good. If you go to the Facebook page, you'll see nothing but complaints about people not getting their orders. So they're just a small startup. But how does the Dwarf 2 fit into this parameter space? Well, again, it's a quad lens system, so good chromatic response, a large array, and a really cheap price. So here we go. The Dwarf 2 is down here in this corner of the space. And it turns out that if you take this line that sort of demarcates the top of the line early smart telescopes and just move it down a factor of 6 in price, that's where it ends up. So the Dwarf kind of appealed to me because it really fit the same sort of performance price relationship that the experiments with the Pi cameras we were doing defined. So anyway, that's a long-winded story about how I'm rationalizing buying one of them myself. Just last weekend, you know, no good deed goes unnoticed. ZWO noticed that people were buying the Dwarf. So at NEAF, they you know, announced something called C-Star S50, which has a 50 millimeter aperture, smaller array, but in price performance mapping, it's almost identical. It's 6% higher performance. Right now, the price is the same, but on their website, they say they may go up to $500 soon. So if you pre-order, you might get the same sort of performance. But the S50 doesn't have doesn't have a wide field camera like the Dwarf does. So I've tried to understand how they're going to observe the sun with this. For instance, in the Dwarf, you can use the wide field and point at the sun really easily. I'm not sure how they're going to do that. So it may have some problems with solar observations, and it's not really, you know, it doesn't have a lot of functionality in the daytime. The Dwarf 2, I'll show you, has some nice terrestrial photography options as well. So I think this field is going to keep expanding, and you know, if ZWO gets into it, then I think a lot of other companies are going to start looking at it too. All right, any questions or comments so far?
Yeah, I just have a question. Can you go back one slide? You know, I'm kind of curious. I mean, the thing that really jumps out at me, I can appreciate your Dwarf 2 story. It's interesting as it is, but that Pi performance For only double the money, you get 25 times the performance. So I'm just curious why you wouldn't have looked at that, and gone for broke.
Well, it's, these are not smart telescopes. So if you want something that, for instance, you can just set up and forget about, and then I'll show you the app. But while we were wine tasting out in Elgin, I was using the app while we're playing Monopoly or cards and taking astronomy pictures. So there's basically no setup, and the user interface is a lot easier. But yeah, I mean, if I'm at home, right, using a cheap camera system with a cheap off-the-shelf telescope is the best way to get higher performance.
Yeah. Okay.
So that's the price. The $400 price is list price. What do I actually spend? I wanted to say, what do I spend from the photons to Facebook, right? So I use a different tripod. It comes with a really cheap, maybe plastic tripod, but I've used something that's a regular camera tripod that is a couple of feet high, so I don't have to bend down on the ground. I use a separate USB battery, and I've gotten up to about 6 hours. I think the dwarf battery may fail. It's got a battery here in the back, and it's kind of too bright. Sorry, but it may fail after only 3 hours. With the battery backup, it's gone for 6 hours, and can probably go longer. I use a really cheap Android phone that doesn't have any phone service anymore. It's just a web only. So all total, I've been using a system that costs about $750. That is really compact and does what I want. I'll show you some other examples where I'm using an L Extreme filter, which is basically the price of the telescope, a couple $100, and a Celestron dovetail and equatorial wedge to get an equatorial mounting for this telescope. So obviously you can add as many accessories as you want, but for $750, I've got a travel system that is really useful. So that's full disclosure on the cost. And here it is. So here's the system that I took to Chicago on our vacation, and it took 20 minutes in the hotel room to put it together. And here's the dwarf as it fits into the same little Tupperware bin. Takes, I don't know, 5 or 10 minutes to set it up. I've got a mini tripod here that's better than the one that was supplied. So if I'm doing tabletop stuff or an easy vertical sort of observing area, I can even fit the tripod in this little box here. So like I said, it's connected to an app, and I've heard that the iPhone app is not good or terrible if you read the web reviews. The Android app has been fine. I've used that exclusively. So I'll go through a little bit of how that looks, and then show you some images. So the first thing to do, obviously, is to connect it. So just hit connect, and it brings up your dwarf address. And I think David brought this up. You can actually connect many different devices to the telescope at once. So I've had 2 cell phones and 1 tablet connected simultaneously. So it's an option for viewing, for instance, in a group of people. The first thing to do is to take astro darks. So, I plug the battery in, packed it back up in the box, put it in the closet, and ran through the astro dark selection. It takes darks, I think, at 6 or 7 gain settings, and stores them in a library that it then uses, for the duration of your observations. I haven't updated them since February, and I don't know if they're going to hold up, as the temperatures increase in the summer. I might expect poorer dark correction, but I'll find out. So far, they've been fine. It's got, let me back up. It's got different modes here on the sort of the right-hand side of the app, and the most, obvious one is the photo mode, just a straight photo mode. And this allows you to point the telescope. This turns into a little joystick, and altitude and elevation. You can adjust the speed, and then For instance, when you're looking at the sun, you'll have two ND filters, one on the wide field and one on the telephoto aperture. So you can get a wide field view of the sun and then center it, and it'll appear in the telephoto version. These weren't aligned at the time. There's a procedure to go through to align the wide field and the telephoto boxes, and I've done that since I took this photo. But in photo mode, it's got a nice feature tracking routine. So you can get this tracking box around whatever object is your interest. And on the sun, it's tracked for 7 hours, tracked for the whole day. It'll drift off a little bit. So it's not dead center pixel aligned for the whole day, but it'll drift off and then correct back to the center of the field of view. So it never leaves the telephoto center field of view. So for taking shots, you have manual shutter gain, and there's actually an IR pass filter that swings in and out of the beam. So you can take that out and pass the IR. Of course, you don't want to do that with the sun, but with nighttime work, it's making a big difference. Your usual stuff. There are other brightness and contrast display controls to help you see things better on your phone app, but I haven't fiddled with those very much at all. In terms of focus, it's got a manual focus and an autofocus. These buttons will move the lens package along the elevation axis to focus. The autofocus works great for terrestrial shots, and I think now it also works for nighttime. They had a little problem with the early software. The firmware version was not focusing on stars correctly, but I think it has been corrected, and I've used it, and it's been working fine for me so far. So yeah, basically you need to focus before you do the go-to. So the calibration for go-to is in Astro mode, and this will give you a menu with 3 different go-to options, and then an image display option here under more. But by hitting the calibration function, it'll you have to manually set the elevation, and you don't want to set it straight up, but at some 45-degree elevation. It'll scan across 3 positions in the sky in azimuth and do a plate solve, and then get the geometry for how the tripod and the dwarf are set up. And knowing, again, the time and the GPS location, then you've got all the information you need to do scanning to specific parts of the sky. So that's what the auto go-to menu is here. This will give you a list of several Messier objects and NGC objects, and then you have a manual selection where you can enter your own coordinates and go there. And then stop go-to is just to abort. So then if you hit the more, then you'll get a display scaling, allowing you to scale the images. And in particular, you can scale red, blue, and green channels differently. And it's just like a normal touch screen. You can touch it and insert another point and move that up and down or side to side. And you can insert as many points as you want to make a nonlinear response if you like. But in this menu, you can also enter the file format that you want to save your data in, the number of frames you want to stack. And I think they're going to change this. Right now, it's stuck at 2x2 binning. I hope that they allow options on that with future software releases. But for Astro mode, it's TIFF or FITS format. So once you've stacked your images, there's lots of ways to transfer the data. They're stored locally on the dwarf in an SD card, and you can use the Wi-Fi connection to download the image to your camera and then do whatever you want, from your camera. You've got a USB-C cable that can provide power, backup power, or can be used to download the data as well. But the easiest way is to just take out the SD card and read it. Although currently it's kind of a zoo. There are lots of different formats and lots of different files. It's like still in, obviously it's still in a debug situation, which, you know, I think is good in some ways too. So like I said, the raw astrophotos are FITS or TIFF, and there's a text file that describes the camera parameters and the coordinates. The stacked image is only PNG. Every time you do a go-to, it saves a FITS image that it uses for plate solving, and a JPEG version of that as well. I think there's a text version as well with the time and the coordinates. Then back in the other modes, in the photo mode, the snapshots are JPEG. In the panorama mode, I'll show you more about this. They're JPEG, but I think there's different resolutions in different folders. I haven't figured out panorama exactly yet. Unfortunately, video is only an MP4 currently. There's no SER save option yet. I hope they come out with that. And it comes with a 64 gigabyte card, but you can insert your own card up to 512. So yeah, it's a zoo, but hopefully they'll make some improvements, especially to the video. So here's some examples. Here's with the L Extreme. So should back up. The dwarf comes with a filter holder that has slots for two filters, one that fits over the wide field and one that fits over the telephoto. And they're 1.25 inches, so you can put in any 1.25 inch filter you want. I've tried using the L Extreme and it can't plate solve with that. So you need to point to the object, point to your target object, and then insert the L Extreme filter. But here's an hour, or just a little over an hour. 15 seconds is the longest exposure. And so here's a stack of 256 on the Rosette Nebula. This is in alt-azimuth mode, and so there's field rotation, actually quite a lot. And you can see some of the stacking errors where it either doesn't scale the frame correctly or it throws out some frames. But yeah, you can see the field rotation really obviously in an hour with Rosette. This is pretty close to the central meridian, so field rotation is high. And here's Horsehead. But instead of just using alt-az, so I think this was from Elgin, I did a rough polar alignment with the tripod and the ball mount. So you can just eyeball Polaris, kind of point it over in that direction. Doesn't eliminate field rotation, but it reduces it significantly. So again, as long as you calibrate the dwarf in that tilted geometry, it'll know how to point to any target. So, you know, this is one of my favorite shots with like 5 seconds on Google Photos. Could crop it and stretch it really easy. And here's M81 and M82 from, again, from Elgin, just an hour with no filters. And, you know, it's a 24mm aperture, so I'm amazed that you can see spiral arms in just an hour with an 1-inch telescope. So here's an example where I tried a more accurate polar alignment. So in this case, this is the Monkey Head Nebula, again with the L Extreme filter. And here, the Sky Hunter mount has a strange wedge that works well with the dwarf. So you basically want to turn the azimuth axis into RA, and the elevation axis becomes deck. And actually I have it upside down in this case because the dwarf has about a 20-degree region where it can't point, and this is the backside of the dwarf, so I had to flip it around. So that sort of zone of no pointing is at the ground. But with this orientation, you can see that the field rotation is reduced. You still get this drift, and there's some, you know, this is again straight out of the dwarf. I didn't try to stack this at all. So maybe we could do something better using the raw frames than what they do in their stacking. Scott Bass decided that he was going to do some real processing on the image. So here he's used astrosurface and topaz denoise on that on the JPEG. And again, for 1 hour with a 1-inch telescope, it's very interesting. Oops, wrong way. Sorry. So, you know, Quiv the Lazy Geek is pretty fond of this instrument, and he's got processing skills that are well beyond me. So here's 4 hours on M42 using PixInsight, and you know, from downtown Tokyo. So again, a 1-inch telescope, it's a pretty amazing result. He's got a great YouTube video. This is probably my you know, reference of choice if you want more information. His YouTube video goes from setting up the dwarf, you know, for the night, going through the app in a more detailed way than I did, pulling off the images and then processing the images. So it's a one-stop shop basically for nighttime stuff. So any questions about any of the nighttime observations or features?
Hey, Matt, you mentioned creating the dark library as one of the first things. I assume there's no cooling going on here.
I don't. There may be some TE, but there's no extra cooling. There's no good cooling like you would get in a normal deep sky CMOS or CCD camera. Yeah. I don't know exactly if they do have some minimal cooling or not, but certainly not anything like you're used to. Okay, so then I was gonna show you some solar experiments and then some terrestrial work that I've been doing with this. So, like I said, the dwarf captures video in MP4 format, and Planetary System Stacker. It's my favorite new processing program. It's basically auto stackered, but it's being supported by the writer. So you can wavelet filter the images that you've stacked with de-stretching. And so this is one of the best images I've gotten from the sun. No filters, just the ND filters. And you know, it's similar to images that I've gotten with the ASCAR and Player One or ZWO cameras. I have an ASCAR 30mm as well. So it's decent. The processing, you know, gives you some artifacts along the limb, and you can't really resolve the penumbra very well. You can see a difference between the umbra and the penumbra at this aperture, but it's interesting. And I'll be bringing this telescope to the annular eclipse in October and also to the total next year to see what kind of images we can take with it. Because it's got an 1.25 inch filter on the front, I've tried some crazy stuff. Andover sells some very narrow filters. They're 25mm diameter, so a friend of mine 3D printed an adapter to get them into an 1.25 inch. So here's something that's around the K-line. It's a broadband filter around K-line, a lot of reflections. So I haven't done a very good job with this at all. I got discouraged when I saw the reflections. Here's an Andover filter, 1 nanometer, very narrow, at H alpha. It's still so broad that the dwarf saturates on the disk, so I need to insert some neutral density. There's also some reflections as well, but I've rotated the image to show you this prominence. There's a prominence off of the southeast limb. And so this might have some potential for being a prominence detector. Even if the disk, you know, doesn't saturate, we're not going to see any chromospheric structure with this kind of 10 angstrom bandpass. But for seeing prominences on the limb, I think it's got some potential. So I'll keep pursuing this. Now, through some daytime options, one of the justifications to bring it on vacations is because I like to take panoramas of places that we go to. We've got a couple of posters hanging up on the wall. So I wanted to test out the daytime functionality. So you can get down to about 3-meter focus, and here's an owl that used to hang out on our front patio. And the altitude and azimuth motors are really quiet, so the owl didn't notice that, but the focus motors were loud, so he was looking pissed off when I was focusing it because he could hear it. Fortunately, he didn't swoop down and take it away. And it can't feature track this, so this guy jumped off of this little perch, and the feature tracking lost him. It was able to follow him while he was moving around on the perch, but if your object is moving too quick in an angular way, it's not going to track it. If a rabbit's in my backyard at about 20 meters, it has no problem following those. So besides shots, it can do time lapse, panorama. Like I said, the autofocus works well, and the Wi-Fi connection is about up to 30 feet. So I was inside while I was taking these shots. So I took it up on the phone line trail up in Sabino. So if you've been up there, you know that where this big flat rock is, it's just after you finally get to the flatter part of the trail. And took a couple of panoramas. So I took a panorama of the far side of the canyon from this perspective, then hiked up towards the top of the phone line and took a panorama of the Catalinas. I'll show you. The stitching program that's in the dwarf had problems, so I downloaded the files and used the Microsoft AISIG composite editor, and actually that's what they recommend doing now. So I think they've given up on trying to do the stitching themselves. But so here's an example. This is, I think it's 13 by 13 or roughly a dozen by a dozen, and it's hard to show all the pixels on a PowerPoint slide. But you can see all the individual saguaro, and if you look up here at this rightmost feature, here's the raw frame that comes from. So actually, on the raw file, you can actually count the arms on each of these saguaro. As you might expect, it's a huge many pixels. I don't know if it's a gigapixel, but it's at least several hundred megapixels of data. And the same thing up near the top of phone line. There's an Ocotillo branch that was kind of waving around and close to the camera, so out of focus. But again, here's the back of the canyon and trail going down there. But then if you look up here on the Catalinas, there's the frame that is in this part of the composite. So you can see individual trees up on the ridge line there. So in terms of making these panorama shots, these high detailed images, I think it's going to be great. I'll be taking it on vacations. Go to France this year, and we'll see how it can do. I think they have a tower there or something. We'll see. So just to summarize it, I couldn't end by saying everything is perfect about this. There's some problems, but because it's on the internet, I'm not sure if they're problems or abuses or both. First of all, this was definitely a problem. They provide a UHC filter that was off band, so it wasn't getting H alpha properly with the first couple hundred that were released. And so they corrected it. The Dwarf Labs people have been very responsive to the feedback they've gotten, and people were provided with new filters for free. I didn't get one of these because I had the L Extreme, but they fixed this problem. The base plate apparently can break off. There's a 1/4-20 screw on the bottom here. Not sure if you can see it, but apparently this little plate is held on by a few small screws, and it's broken off for a lot of people. I've had no problems. But Dwarf Labs hasn't handled this so well. They say glue it back on, which maybe that's a common sense fix. And hopefully they're working on strengthening it. Obviously, some people have been able to break it. I haven't, but maybe through other use, it could. Some of the optics in humid environments sometimes get fogged. Tucson, obviously, we don't have that problem, but some of the ceiling may not be up to snuff. And then these are definitely abusive things. For some reason, people keep wanting to image planets with this. And so they're gluing on all sorts of filters onto the front. Lenses onto the front and seeing if they can get higher resolution, magically breaking the laws of physics. I haven't heard any success stories. So yeah, I'm not sure I would trust whatever this guy says on the internet. And then finally, I don't know if you guys can guess what this is. This is a 3D printed mask that fits over the telephoto. Any ideas about why this guy did this?
Try to focus.
That was a side option, and people have made focus masks, but this guy just wanted diffraction spikes on his images of stars, so he made some cross beams. So I don't know. I'm not sure if that's abuse or creativity, one of those two. So there are a lot of people doing some crazy stuff with this system, and for $400, not a lot lost if something breaks, I guess. All right, so that's all I had. I think, like I said, the Quiv Lazy Geek YouTube video is probably my favorite. Okay, so here's another point too, though. If you wanted to try it out, there's a couple of Facebook groups, and one guy on the Facebook group from Australia, the dark site, is trying to give away data to people because he doesn't like processing it, he says. So if you're curious about what the data looks like and don't want to buy one yourself, check out the Facebook group. And just yesterday or 2 days ago, this guy Trevor Farrell was offering to upload his raw data to a Google Drive for anyone to fiddle with. And then Cloudy Nights has a couple of threads. But again, don't believe everything on the internet. I wanted to end with this little image, which I think says that the Dwarf 2 has made it to mainstream, because here we have a really lazy fake Photoshop image from the Dwarf 2. First quarter moon can't get this close to the horizon in this orientation, but this is my pet peeve. People have earth shine that's darker than the clouds, and that's physically impossible unless the moon is in front of the clouds. So yeah, the Dwarf 2 has made it to prime time when people are photoshopping fake images using it. All right, that's all I had.
All right, thanks, Pat. That was great. Any questions for Matt? Well, I have a question. Are they going to keep the price at $400? It seems like you might be able to kick that up somewhat.
Yeah, that's a good question. I think ZWO will give them a bad example. I think ZWO is going to go up to $5. So it may not be 400 for very long.
They sent out a survey to ask exactly what you would expect them to do next, apparently. And one of the question was, would you like the system to look more like Apple or ZWO in terms of fit and finish? And they also had something in there about raising the price a little bit. So they're actually tweaking the consumer base to see exactly what people are willing to go with.
Yeah, I think they started out with the Android PC community in mind. I certainly got that working first, which is great for me. But
you showed a pic of the ZWO device that just was released, and it mounts on a regular tripod. Does it do alt-az tracking as well, or do you have to do something else with that?
Yeah, it'll do the alt-az tracking. I've heard a rumor that you could also mount the ZWO, on a wedge that was pointed toward Polaris, but it's so new. It came out, I heard about it Friday, so I don't know anyone who has one or has tried those things yet, but I wouldn't expect it to be very different. If they're doing plate solving like the Dwarf people are, then should be able to tilt it at any angle and do that.
And the plate solving uses an internal database.
Mm-hmm.
Okay.
Yep.
What's the wait time on them now? Do you have any idea?
Oh gosh, a couple of months. Did you just order one, David?
I ordered one March 1st, and I didn't get it yet, but I got the notification that UPS has assigned a tracking number to it, which means that it's probably on a slow boat from China heading this way. So maybe in another 6 weeks.
Yeah, it's actually been fun to learn about all those. There's ways to track those boats. I never knew that, but Facebook page is full of those.
I just ordered one at the end of March,
Excellent.
and the boat just docked at Long Beach on Sunday.
Here you go.
So just took a couple weeks. Hey, since I'm going to be new to this thing, oh, by the way, I'm new to the forum here, the group. So any tips for the newbie on this dwarf?
Yeah, I would say that watching Quiv the Lazy Geeks YouTube is
Yeah,
the best way you can
Yeah.
spend your time.
I've
And
been-
then there's a guy on, there's a lot of negative posting on that Facebook page, but there was one guy that came out and said, I looked at 3 or 4 tutorials and then I finally got mine and I'm really happy with it. I've never done astrophotography before. So I think a lot of the people that are having these bad experiences are just not prepared.
Yeah, that video by the Lazy Geek, I just watched that today. It'll take you from setup using Cyril to do the, which is a free program, and get it up to where you could then put it into GIMP and fine tune it. And then he compared it to what is it?
Insight, yeah,
Yeah, PixInsight, the one that all the big guys use.
all these
But-
guys. Yeah.
But it was a good video. I mean, if you've never seen it, how this is done, and you want to start off with not spending a lot of money on the software end, I'd recommend that video also.
Matt, how does it perform for like viewing it by a group? I mean, you said you can stand around with a couple of phones. Is it before it does a lot of live stacking? Do you get pretty decent images?
Yeah, it'll depend on your location, obviously. When we're up in Elgin, yeah, in just 3 or 4 minutes, I was getting M81, seeing the spiral arms, and everyone around the table was thrilled. Out of my front yard on Saturday night, I set it up, and it wasn't quite as dramatic, but you can see the galaxies certainly, and with the right stretching on the histogram, you can get some decent images in 4 or 5 minutes. And David, you were the one who was thinking about using it with a group of students, right?
Right.
With everyone connecting.
Right. And I asked that question, and I was surprised that people were doing that. So yeah, it's pretty well. Hopefully, it's going to be pretty handy for outreach. So we'll see.
Can you zoom in on the tablet or the cell phone
Oh yeah,
with the 2-finger?
yeah. It's got the whole zoom, pan. Yeah, it's a normal cell phone experience that everybody who's half our age understands. From the cradle.
And it works with tablets too, I guess.
Yeah, and David, you're the one who inspired me. I've been using the Samsung tablet. It's only 8 inches, but it's a lot better than the cell phone screen. And yeah, that's a really nice way to show a group of people.
You could also use like Easy Share or one of those programs and send it to a projector and then just project it on a screen. And so that's another option as well.
Matt, I've got a question for you. You were imaging the sun. I think you said that you had done a video of the sun, and my question is, how does a plate solve its way to the sun?
Yeah, so it doesn't. And so for solar daytime work, I really have to rely on that wide field camera. So looking at shadows on the dwarf, you can get it approximately pointed to the sun. And in that case, the sun is in the wide field of view camera. And then you can just use the joystick to move the sun to the center of that, and it appears in the telephoto. And then after it's in the telephoto, you can use the feature tracking, and then it'll follow it all day.
Ah, that's how you did it. You used the feature tracking function.
Yeah.
Okay, I got you.
But at 3 arc second pixels, it takes a while for it to drift across the telephoto field of view. So I think for those movies, I may not have even figured out tracking by then. I just took 5 or 10 seconds of MP4 movies, so a couple hundred frames, and then processed that in Planetary System Stacker.
Of all the scopes that you were referring to earlier, I believe that's the only one that I've heard of that has a feature tracking function.
Right. I think that's right.
That's an interesting add-on.
Well, people are using this for birding, for instance. It's a really good device for tracking birds. I've seen movies of planes, people tracking planes taking off. So yeah, it's got a lot of terrestrial applications, but it does work for solar work very nicely.
One of the interesting things, looking at the specs and then what people have been posting, it seems that the electronics is very similar to the ASI Air Pro in terms of the plate solving capability. I mean, that is really fast when you turn that, and centering, it's just incredible. So I'm thinking that they may have some, I don't know, cross pollination with that company, but it's impressive.
I had a question about, your daytime hillside panoramas. I'm wondering if you've taken any Milky Way shots with that.
Yeah, no, I haven't. And people are asking about that. They're looking at allowing control over the wide field camera so that you can get a much wider field of view to start to take Milky Way shots. And then, yeah, people are asking for an astro panorama function. They have not installed that yet, but there's some talk about it.
Good. Anything else for Matt? All right.
All right, thanks.
I think David Stern, are you still on?
Yep, right here.
Did you have a image or something that you wanted to share?
Yeah, I just wanted to share how I've been doing these Hubble palette-like HSO images using a script, pixel mass script that I got from Bill Blanchard. Talk about that. Can I share the screen?
Sure.
Okay. And let's see. The best play it is oh boy. It has me do system preferences here. I'm sorry. Let me go ahead and turn that on. And I gotta use my password. Okay. Can everybody see it?
Not yet.
How about now?
Not yet.
All right, let me go ahead and try again. Share screen. How about now?
There you go.
All right, great. And let me get rid of this thing. Okay, so you can see all the panels, correct?
Yeah.
Good. Let me go ahead and find this. All right, so I've been doing this since January. You know, I'm the new kid here on the block, if you consider 66 a new kid. And just starting to get to the point where I understand the workflow of PixInsight, and I've been scouring the internet and YouTube to gain as much knowledge as I can. And one of my objectives was I saw these great images using Hubble palettes. And I didn't even know what a Hubble palette was at the time, but I came across Bill Blanchard's YouTube channel called Another Astro Channel. And actually Sean Nielsen was the one that I discovered this whole technique with. So what Bill Blanchard has done is he had a company, I believe it was a robotics company or electronics company, sold the company, made enough so he could retire. And his idea of a hobby is writing pixel math scripts. And he shares these scripts for free. He's designed these so that people like me who are brand new can start using them. Luco is another YouTuber that has developed a technique of providing a Hubble palette-like look using PixInsight itself. But then my understanding is he actually collaborated with Bill, and Bill wrote pixel math scripts to do basically the same thing. It's considered normalization of narrowband imaging, and it's designed for people like myself that have an OSC camera. It's also designed for people that do, filters and do RGB imaging as well. The HOO normalization script is the one that I typically use. It's designed primarily for OSC, but I have used the SHO as well, and I've had some great results with that. Initially came out with these scripts and there really were no parameters unless you wanted to go into the code and changed it. But now what he offers is, you could see the pixel math window, hopefully. He has all these different levers you can choose. So again, I used an IDAS narrowband filter, the UHS version for the Hyperstar. So you can change the mode, whether you want to use regular normalization or C normalization. I usually set mine for C. And then you could choose the blend mode if you want to get the type of look that Lucomatico developed using PixInsight. You would choose 0, and then you could choose your luminance depending on the image. I chose 2 typically for this because it has all the HA data in it. It'll emphasize that for luminance. And then it has a mask feature. I'm not even sure what that is. And then it has a blending capability. And if you want this to look more like an SHO image, you'll raise that factor. But right now, the default is 0.6. Then it has the ability of increasing the O3 boost. And if you get to the point where you're starting to clip your image, like you could possibly get with the Rosetta Nebula, then you can use the HL recover. But I found for this particular image, I shot it at 30 seconds and I did 400 sub exposures with it. I didn't have to worry about blowing out the image. Actually, the core came up pretty decently. So it's really simple, and you can actually, clone your process here, and you can make it into your own. If you want to change these settings and save them all the time, you can do that. So, for example, I have one that I labeled Dave's HOO for this image, and all I have to do then is lay it on top. And now you can see I have a HOO or a Hubble palette type look. Then I would go typically further. This is a starless image. I actually used Star Exterminator prior to getting this all set up for you. And I ran it through, and it's now a nonlinear image. I went through DBE, all the standard stuff to get it to that previous image. And I even created a little color saturation icon now where I can just go ahead and add as much as you want or as little as you want. So, basically that's the basic concept. And as I was starting to learn how to use this, I applied it to some other images. So a couple of weeks ago, one of the few nebulas I could actually capture was the Cone Nebula. And here's an example of that image after I completed all the processing using the HOO palette or script, and then did processing in Lightroom as well as Photoshop for the final touches on it. But that's one example of that. Using the HSO routine, this is the example you can get with that. Hopefully you can see that okay on the screen. And then the Jellyfish Nebula, I was even having some fun playing with this. So These are available for free on his another Astro channel YouTube site. The latest video features his version 5 of these scripts. And then he also includes the ability of adding additional downloads that he has for star reduction, HA to RGB. I haven't even touched these yet. But he has like probably a dozen or so scripts that he's developed over time that he provides for free. I know not everybody likes this type of look. I happen to for myself, but again, it depends on your taste. But that's all I wanted to show you.
Very good. And David, if you could send me to my email the links to the stuff you've described,
Oh,
I'll
absolutely.
be happy to post those when I put everything together for this meeting.
Yeah, and I've become Facebook friends with Bill. In fact, I've messaged a few times just to ask him his opinion about some of the images. And I said, you know, you should really be selling this stuff. I mean, this stuff is worth something. I'd be happy to pay you, but he refuses to do so. He wants to keep it free. He developed this for new timers like myself, but I figure the way I look at it is it's like anything else. When I started out in photography 20 years ago as an amateur, I studied as much as I could, and then you kind of get into your groove and you know what you know, and you don't need to know any more about Photoshop. And I figured, you know, I guess the whole thing would apply with astro imaging, that you know what you know and you're used to it, but this is something that's brand new. And for someone like me that's absorbing stuff like a sponge now, I just thought I'd share it with everybody. And I'll send that to you.
Dave, can you hear me?
Yes.
I just wanted to tell you that I have been following your work on the forum, and I was so impressed with your work that I went to Blanchen's website and downloaded all of his various pixel math programs.
Oh, cool.
I haven't started playing with them yet, but I was very, very impressed with the quality of the work that you were putting up.
Well, I do appreciate that. I'm still learning. I took Adam Block's course on the fast track training, and then I've just started doing the fundamentals. And I don't know if any of you have taken his courses, but he goes into a lot of detail, more so than what I've seen elsewhere. And I was struggling just going through YouTube trying to find something that would work so I could learn how to use PixInsight. But nothing was really cohesive or structured, and that's what I liked about Adam's course. But I do appreciate the comments. I've completely become obsessive about this hobby now. Ask my wife about that. This is all I do. So I'm really excited with the results I've been getting so far.
Okay. Well, anything else that anyone needs to bring up? Okay, I've got a couple of announcements. At our, I think it was last month, we discussed the possibility of having an in-person meeting. And I was able to get a room at the Oro Valley Public Library for the third Monday of next month. That's May the 15th. And so we're going to have an in-person meeting for those who'd like to attend. And I'm hoping to be able to make it a hybrid meeting so that it'll be Zoom as well. The library has Wi-Fi and a projector, so I'm going to check it out, and hopefully we'll be able to have a meeting. So those of you who want to see what I look like in person can do so. And we may even have refreshments. So I'll send out a notice about that with the specifics, but that's next month, May 15th. It'll be a meet and greet meeting and share some images as well. And then for our July meeting, we're going to try to do what we did last summer, and that is have a monsoon challenge. Those of you who've lived in Tucson for a while know that the monsoon season starts whenever it wants, sometime in the summer, and usually clouds over for a month or two. So the monsoon challenge is to try to get folks to image the same target and get it, between the monsoon clouds. So the two targets for this year's challenge are M92, a globular cluster in the constellation Hercules, and M27, the Dumbbell Nebula in Sagitta. Those will be the two targets. You can shoot either or both of those. Give it your best shot once the monsoon starts, anytime between now and July the 17th. And then when July the 17th, we'll have everybody upload their images and compare what we got. So that's a couple of announcements for the next coming months. All right. Very good. Thanks for your attention, and I'll try to have the recording posted sometime tomorrow for those of you who want to go back and review what we've discussed this evening.
Great meeting. Thank you.
Okay, thanks.
Enjoyed it.
Have a good night.
Good night.
Thanks, Greg.
Okay.